Hey everyone, welcome back to lesson 4B, where we're going to be talking about the interaction term for the GRCBD. Specifically, we're going to be talking about how do we test it. We're going to learn some new terminologies like co-directional and anti-directional, and when we are or are not allowed to test for the treatment effect. And all this is going to be related back to our reaction time example. So let's get started with talking about the test of non-additivity, or you could also call it the test of interaction. The important thing to remember is that whenever we have an interaction in our model, you always want to test the interaction first. We will talk more about this when we have two treatment factors in the factorial design coming up in the next week or so. But what our interaction test is going to measure is the magnitude of the block treatment interaction, or the deviation from additivity. So recall that when we have an additive design, so the RCBD, we had parallel lines. Whereas the non-additivity design interaction plot didn't have parallel lines, or they're going to cross and it looks maybe something like this. And so our hypothesis test for the test of interaction is, do the terms all equal zero, or are there some that don't equal zero? Another way in more words, the null is saying there's no interaction, i.e. parallel, versus there is interaction. All right, our test statistic for this case is going to be the block treatment interaction, so our SSBT divided by our degrees of freedom divided by the MSE. This test statistic will follow an F distribution where the degrees of freedom for the numerator are this, the degrees of freedom for the denominators here. We will reject our null, where our null is that there is no interaction, and conclude that there's a block treatment interaction if this value is greater than our cutoff point, or if our p-value is less than or equal to alpha. So let's get back to our back to our reaction time example. Oh, it's right there. I'm losing my mind today. Go like this. And in this example, recall that we were trying to test the influence of alcohol, where we had the treatment of 0 ounce, 1 ounce, 2 ounce. We had a block factor of age. And in each treatment block cell, each treatment was randomly assigned to 4 individuals in each block. Okay, so this is telling us that we have replication, this bold part. Our hypotheses, again, no interaction versus interaction in our ANOVA table. Here is our F test for our test of interaction. Recall, we don't have an F test or a p-value for block. The reason it's not here is because I made this table. In software, they'll give you these values, but again, we got to be smarter than our software and remember not to look at those values for the block. Okay, so since we have a large F stat or small p-value, we're going to reject the null and conclude that the effect of alcohol level on reaction time for some groups are different. So we're saying that there's an block treatment interaction. That is, the alcohol affects differently based on your age. And if we think about this, this does make sense. As we get older, our reaction time as we drink more alcohol probably differs from when we were younger. So it makes sense. When we look at interaction, the first thing we do is to test it. Okay, so we saw here it's significant. Now we have to almost take a step back to think about what does this imply. And to do this, we're going to look at our interaction plots. Again, the interaction plots are plotting the estimated cell means. And there's two kind of concepts, co-directional and anti-directional interaction. Let's talk about co-directional first. It's also known as orderly interaction in textbooks sometimes. So co-directional is the interaction plot where it shows it's not the exact same, but similar trends. Okay. So they're moving, you can notice that they're moving in the same way. They are crossing, so there is interaction, but they're moving kind of in the same direction. This case implies that we can do inference on our treatment effects. It's still interesting. All right. With anti-directional, the interaction plot's going to show different trends for some blocks. So this one's going up, these two are coming down. And so the inference on the treatment effect for alpha does not make sense, and it's not interesting. Okay, let me repeat that one time. If we have co-directional, similar pattern, we can do a test of treatments. If we have anti-directional, so we have the lines moving in different directions, we cannot do test of our treatment effects. We will spend more time with these topics when we get to factorial designs, but introducing it here right now, I think is beneficial. There we go. All right, so let's talk about, we just talked about doing the test of interaction. Once you do the test of interaction and you see it's significant, you want to start looking at co-directional and anti-directional. If it's co-directional, we can do the test of treatment effects, if that's what your research question is getting at. If it's anti-directional, you cannot do the test of treatment effects. And we'll explain that just a little bit more in a second. So let's look at the test of treatment effects. If we want to look at the treatment effects, i.e. our research question is looking at how the treatments differ, we can do this with stuff that we've already seen, where we have our sums of squared treatment divided by our degrees of freedom over our MSE, with this following an F distribution. And if we will reject the null and conclude that, I'll fix this, that there's a treatment effect. There are some caveats that we will talk about. So, what if, this is a question that we're going to kind of look at a little bit more. So what if the interaction is significant, but the treatment effect is not significant? So what this could look like is we have our F for interaction to be large, implying that our p-value is less than alpha. So we're going to conclude that there's an interaction effect that's significant, it's there. Then our treatment, so our F of our treatment is small. Again, large and small are relative, but we're saying that the p-value is greater than our alpha. So we fail to reject H not here. Okay, so we're saying there's an interaction, but then the treatment effect comes back as not significant. This could mean that the treatment still plays a role in contributing to the total variability in the treatment block interaction, but it's super wrapped up in the block and interaction term. Also, the treatment effects within the blocks are canceling each other out to make it the illusion that the overall treatment effect isn't significant. I think the best way to really understand this is to draw a picture. That's why I gave us some space. So let's consider we have the interaction plot, treatment A, B, C. We have block 1, maybe looks like this. And we have block 2, which might look something like this. Okay. Our y-axis is our mu hat ij's, our estimated cell means. Okay. Our purple is maybe block 1. And our light blue is block 2. So I would say this is anti-directional interaction. And again, our p-value for our testing whether interaction is here or not, it's going to be really small. We'll just say our p-value equals something super small. So treatment block interaction is significant. But if we were to look at the effect of the treatment, so we're going to average out the block effect. That is, we have treatment A, B, C, and we're going to average these 2 points. Blue and purple don't make pink, but we're going to say it does today. So take these 2 points, get that. Take these 2 points, average them, get this. Take these 2 points, average it, and get this. So we have a line. This y axis is now the yi dot bar. So we're averaging out the block effect. Then we would have a straight line. This is also going to be known as the main effects plot, which we'll talk a little bit more about in a second. And so our question here is, does it look like the treatment has any effect here? And since it's a straight line, I'm going to say no. There doesn't look like there's a treatment effect at all. And if the treatment has an effect, it's really wrapped up in the block treatment interaction. And so in this case, the test of treatment effects in the ANOVA table will be misleading. Again, this is anti-directional. We probably shouldn't. And this is also helping us to understand, if we have anti-directional, the idea of testing just the treatments doesn't really make sense. Now, if we had co-directional, we don't necessarily see this pattern. The problem is that sometimes you're in between, so you'll have to use your judgment. You won't be wrong if you only look at the interaction and stay just in the interaction term. It really depends on your research question. So if you're interested in looking at the difference in treatment effects. Now let's go back to our reaction time and look at the interaction plot for that. So here is our interaction plot for our reaction time. I would say that this is co-directional interaction. And again, you'll notice that these lines don't cross. And so this is why in the last video I was talking more about slopes. And so we need parallel lines for interaction, but if we examine the slopes of these lines right here, we can see that they're not the same. They're different. And so what this is saying is for block 3, this green line that goes from 1 ounce to 2 ounce, has a larger effect on the reaction time compared to maybe this younger group, because this is the youngest group. So it's all about looking at those slopes to really help us understand if there's interaction or not. So again, technically we don't see the lines cross, but for non-interaction, we would expect the slopes to be almost exactly similar. So instead of this line being very steep, we'd expect it maybe to be less steep, similar to this slope. Now, a limitation of the interaction plots is that we don't have any error on it. That is, we're just plotting sample statistics. So this is just the cell means of mu ij. And so we can't make complete conclusions just using this picture. But using this picture or the interaction plot in conjunction with the ANOVA table gives us a lot of information. All right, recap. I think this is co-directional, and we're saying that there is an block treatment interaction. Something else we want to look at now would be the main effects plot. And so we just said that there's co-directional, block treatment interaction is significant, and maybe one of our research goals is to look at the difference between treatment effects. Okay, so the main effects plot is going to show us the pattern of treatments averaged over block. So if we're asking ourselves, so we want to now ask ourselves, does this pattern seem similar to our interaction that we saw over here? Not the same, because if this pattern and this pattern were the same, that means that there was no interaction here. So we just want to see if the patterns are similar. If yes, then we probably have co-directional interaction and the test of treatment makes sense. So if we're looking at these two, do we think that they're a similar pattern? I would say yes. They're both kind of increasing. To me, that is a very similar pattern. So in this case, the test of treatments effects makes sense. Okay? But the conclusion may differ. Oh, that's a bad eye. Depending on the age group. So what we mean by this is if we look at the slopes on the main effects plot, so from here to here, let's just say this slope right here, we would see that the slope would be significant. But if we go back to the interaction plot and look at the slope within just block 1 from treatment of 0 ounce to 2 ounce, we might not see the exact same results. Okay? So the point here, and it will again depend on our research question if we want to just know alcohol by itself, because our main effects plot is looking at alcohol by itself. That's why we're averaging out. We can make a conclusion about alcohol. So here we made a conclusion that, well, we actually have it because we haven't looked at p-value. But with the main effects, we can make a conclusion about alcohol. But here's the big but, the caveat, the warning. We also have to say that these are conclusions we are making about alcohol. However, we understand that it is involved in an interaction with an age group. So certain age groups may not exhibit this pattern. That will cover you. Let me repeat that one more time. Our main effects plot is looking at the treatment. Do these treatments differ? So if our research question is solely about making a conclusion about the alcohol treatment, we can do this, but we also have to give the warning to the people we're talking to or we're writing in a paper. There is an interaction with age group, and that while this may show significance, within age group might not show significance. Okay? You're just giving a warning to your people that you're talking to. However, if we were back in our anti-directional, again, this was co-directional. If we were back in the anti-directional example before, which was here, we can't even go into discussing main effects and treatment. All right? You can't make a claim at all. So we look at the interaction, we look at the main effect, we establish there's an interaction. We also established that there is co-direction. So we are interested in the test treatment effects. It is similar as before. You look at your hypotheses, you look at your F-test, and here we can conclude that we reject H0 and conclude that some of the 3 alcohol levels differ effects on the reaction time with the caveat that this might not hold true for all groups or all blocks. I know I talked a lot in this lecture. As a recap, if we have interaction terms, we want to test that first. If we decide that the interaction term is significant, we then want to look at interaction plots for, that's not the right page. We want to look at the interaction plot for co-directional or anti-directional. If we have co-directional and our research question of interest is looking at the treatment effects, we can then proceed to look at our main effects plot and do a hypothesis test for treatment effects. If our interaction is significant and we have anti-directional interaction, we cannot do the treatment effect. Okay? That's going to wrap it up for this lecture. I hope you have an amazing day as always, and I will see you in the last lesson for this week.